right? So overall, what we are studying? We are studying TLS. To understand TLS, there are four different things: confidentiality, integrity, authentication, and non-repudiation. We are starting with confidentiality piece, right? To understand why confidentiality is so important, I would like all of you to take to maybe in the era of World War II, right? And that is why I am showing two types or two different kind of soldiers here. We have allied forces here. What is the meaning of allied forces? Meaning of allied forces were USA, England, and Russia. And there are Axis powers too, the other hand, right? And in Axis powers, we have Germany, we have Italy, and we have Japan. And this is a huge event, World War II. People were losing life, right? And interestingly, the outcome of this war or the World War II was dependent on a security breach. If you understand, if you know about it, it is good. If you don't know, try to understand the impact of security on an event like World War II. It's a huge event in the history, right? Now, I would like to tell you a story from the World War II. There are two different forces, Axis powers and Allied forces. There are different nations in that, right? So actually what happens? Generally, we have a higher ranking officials of the army who sits and plan everything, right? And whatever they plan, they send this information to the officers or the soldiers on the field, right? And this communication should be absolutely secure. Why? Because if other party can decrypt this information or can take this information, they will know the strategy of the other part, right? So if allied forces came to know about these messages, then they can plan well, right? So the security of these messages was really, really important. And that is why Germany was so sure on its security principles or the security technology. They send these messages in a way such that if other party or if an intruder can take these messages, he or she will not be able to get anything out of these messages. It means that if they want to send a message like the next attack should be from this location, that message you can read, right? Or that message is actually in a form of maybe hashes, exclamation mark, or something else, right? You can read that this is hash, this is exclamation mark, but you cannot get meaningful information out of it. It means Germany is scrambling these alphabets. And most of the time, allied forces were getting all these messages because they have the good interceptors also, right? But all the times they get these messages in this format only. And that is why they couldn't get all the information. And the information which they can get from these messages is huge. If allied forces can read all these messages, means USA, England, and Russia, if they can read all these messages, they would know in advance from where the next attack will happen. Interesting, right? And try to understand the value of security. Every day, if I think there is a calculation that every day approximately 30,000 people were losing life in Second World War. So what happened? Germany was so sure that nobody can break or nobody can read its messages. And Germany has created a machine. The machine name was Enigma. And they call this as an algorithm, which is they use to generate the messages which are unreadable. These messages can be read only by these field officers, right? So what was the process? The process was simple. They have some initial setting, and after this initial setting, they type the message. Once the message is typed, it is scrambled because they have some initial setting. So this guy will send this initial setting to the field officer. Field officer will be having the same machine, and with the same machine, they will be having the same setting, and they can read the message. But these settings are not known to allied forces, although allied forces have this machine, but they do not know the settings. They do not know what was the setting of these routers while typing the message, and that is why the decryption of these messages or reading these messages were almost impossible. But believe me, in Britain, there was one gentleman who was actively working on how to break these messages. The gentleman name was Mr. Alan Turing. He created first machine, and we call them in today's world as computers. So the first computer was built by this guy, Alan Turing, right? Very interesting machine. And through with the use of that Turing machine, right, he has successfully decoded the messages from Germany. Germany was so confident about its messages that nobody can break it. But somewhere in Britain, somebody has broken these messages, and now Allied forces means USA, England, Russia was able to read all the messages, right? And they knew in advance from where Germany is going, or Germany, Italy, or Japan will going to attack next. And they were fully prepared for that. Believe me, only this work, which is done by Mr. Alan Turing, reduced the war by 2 years. 2 years, believe me, right? Every day 30,000 people were losing lives, so you can presume, you can do the calculation, approximately 23 million lives were saved by this guy. Interesting, right? But why I'm telling all these things to you, the only reason is that security has major impact. It has major impact in the history, because the Second World War was won by Allied forces, and one of the major reasons of winning was breaching of these security messages. Right? Interesting. Germany was uh, so sure about its confidentiality in messages, and somebody has broken that confidentiality. Right? We all know that we all do our banking transaction, all the transactions on internet, thinking that everything is confidential, right? And of course, whatever the algorithm, of course, we are not using Enigma right now, right? There are some different algorithm which we are using, but try to understand. If we are saying that today's algorithm can't be broken, it is not a true statement, right? It could be broken. Maybe we do not have those computers now, which maybe somebody will build someday, right? So if Enigma can be broken, confidentiality algorithm can be broken, whatever we are going to see. But yes, right now, if the internet is working on them, we should be rest assured that nobody has broken down those algorithms which we are using in today's world. But what is the meaning of that algorithm, right? So I would like to take you to the next board from here, and let's try to define the meaning of confidentiality. Let's introduce some terms now. So we have two different kind of messages. This is my message number one. We all can read it. It's written, "Hi there, how are you enjoying learning security?" Absolutely, we are enjoying learning security. And now somebody has changed this message to this message, and nobody can understand what is written here. But I can tell you that I can convert this message again from this message to the message number M1, right? So the message which you can read easily, which is written on this plain paper, is known as plain text. First term I am introducing now. This is my plain text, right? And if I scramble it using some step-by-step manner so that I can convert it again back to the plain text, the middle form, which can't be read by anybody, is known as ciphertext. This is my ciphertext. So it is going to be great that if I want to send my message M or M1, I am not going to send in plain, right? I will be changing it to ciphertext, and over the unsecure medium like internet, I will be sending this ciphertext, right? So that nobody can read it. And once this message reaches at the destination, I can again convert it back, or the destination can again convert it back to plain text so that they can read it. So only the source and destination can read it because they know the rules which converts a plain text into the ciphertext. And by the way, this process of converting plain text into ciphertext is known as encryption, right? So this message, the message number 2, which you can see right here, is my encrypted message. And the process or the rules which I use, or the step-by-step approach which I use from converting this message from plain text to ciphertext is known as algorithm. Interesting. And by the way, this machine, which name was Enigma in the Second World War, that was kind of an algorithm, right? And the settings in that machines, right? By the way, anybody can know this algorithm. So there must be something different. For example, it if I talk about that machine Enigma, right? This machine Enigma was with allied forces also and with Axis power also. It doesn't mean that if you have a message and allied force also having this Enigma machine, they can decrypt it, right? The beauty is not in the algorithm, or the security is not in the algorithm. The security was in the initial setting of this machine. Because allied forces was not able to know the starting setting of this machine, that is why they were not able to decrypt the message. Algorithm basically is available everywhere, believe me, but the setting which is known as key in today's world is not available to everybody. You should have algorithm plus key, but what is the meaning of this key? I will tell you in the next board. I think the takeaway from this board is very simple. We have plain text, we can convert it into the ciphertext using an encryption algorithm, and the process is known as encryption. As simple as that. By the way, Mr. Daniel just said, whatever I just told about the Second World War, it is from a movie called Imitation Game. Believe me, if you don't watch my video, have a look at that movie. One of the most interesting movie which you have seen. Very interesting movie too. Every security engineer should see that, right? Having said that, let's move to the next board where we will be talking more about confidentiality, right? So in this board, we will be talking about more in terms of algorithm and key. So if you do not understand the meaning of algorithm and key, that is perfectly fine because we will be talking here. So we have Miss Anjali here. Miss Anjali is having her laptop right here. We have this internet connection. We have Mr. Rahul, his laptop, and Miss Anjali wants to send a message to Mr. Rahul. And she wants that if anybody is in the middle, he or she should not be able to read my messages. And that is why she is sending a message. And message say A, B, C, D. Interesting. If she is sending A, B, C, D, of course, intruder and Mr. Rahul can read it. So she is changing this message. And she is thinking hard. She's saying, I will not write A as A. I will write A as Z. I will write B as A, C as B. So one position left. If that is the case, if she wants to send A, B, C, D, she will be sending message Z, A, B, C. This is the message which she is going to send. This is my plain text message, and this is going to be my cipher text message. But interestingly, this is not a very good algorithm. Why? Because Mr. Intruder can understand this, that Anjali is actually moving one step or one one step left. Interesting, right? So basically, Anjali is using this number, which is also known as key. So the algorithm was simple. Algorithm is just change the characters, right? But how to change the characters? It depends on this key value, which is -1. -1 means that we are moving left one place. If I talk about -2, Anjali will be replacing, right? Anjali will be replacing A with maybe Y, B with Z, C with A, D with B, and so on. And now the message can be if she used, so this is the ciphertext when she was using a key value of -1. If she used key value of -2, the changed value or the ciphertext will become what? The ciphertext will be YZAB, as simple as that. But still, this kind of encryption, this kind of scrambling is not that great. Maybe you can introduce some more complexity and you can write -22. Interesting, right? So the algorithm here is to change the alphabets. By what to change the alphabet is the key, means -1, -2, -3, -4, whatever the value you are writing here, this is the key value. So if you are encrypting a particular object or if you are encrypting a particular message, you should be having two different things. One is the algorithm, right? And the second thing is the key. I know I have taught this board to many people, but still people do not get the concept of key here. And that is why I am introducing one more board to you so that we all are on the same page with respect to key and algorithm. So this page on the right hand side, right here, I have a safe here, right? This safe is having some key combination here. And somebody has put maybe some jewelry inside it. Inside the safe, we have jewelry, right? So what people are doing, people are bringing, and this jewelry is of high value, believe me, and everybody want that. If that is the case, what people are doing, people have bought this safe, right? And they are researching this safe, just like Enigma machine. For example, Enigma machine was developed by Germany, but Allied forces were able to get one of the Germany or the Enigma machine, or maybe some of the Enigma machines, and they were doing research on this Enigma machine. It is as good as that if you have a safe, you can buy the same safe and doing the research to open it. This safe is not going to open unless and until you know the key combination, right? Whoever placed all these jewelry inside this box, they must have the key value or the password. Maybe the password is 32769, suppose. Nobody can open it until and unless they know this password. Doesn't matter how much you study this safe, until and unless you get this key value, you are not going to open it. So just try to understand, if I'm talking about safe, it is as good as algorithm. It can be public, it can be known by anybody. But the important piece is key, right? 32769. And this is the same principle with Enigma. Enigma machine can be with allied forces or Axis powers. But until and unless they know the key value or the starting position of these motors or the rotors, right, they won't be able to get the messages. And that is why Alan Turing was so brilliant. He developed a first computer to break this mechanical computer, you can say, right? Now, another example, if we have lock, this lock you can get, right? And study this lock, how this lock works, but until and unless you get the key, you cannot open or close it, right? So I think by this board, now we are in good position to understand what is the meaning of algorithm and what is the meaning of key. Algorithm can be everywhere, right? You can distribute algorithm everywhere, but without the key value, you cannot open it. Having said that, now we are in good position to understand one specific form of confidentiality or encryption, which is known as symmetric key encryption. Again, we have Miss Anjali here, and we have Mr. Rahul right here, and Miss Anjali wants to send a message to Mr. Rahul over internet. Just wait a minute. I'm starting again. So we have Miss Anjali Rahul over internet, and Anjali wants to share a message or send a message. And one interesting thing, Anjali has a secret key. The name is K1. By the way, in computer science, whatever you see, those are numbers, those are binary numbers, right? You all know. So if I say K1, it is a number. I am representing that number with this key, right? Green key. I'm not sure, but Anjali, through some way, has shared this key with Mr. Rahul also. How it is going to be very interesting. By the way, I will be telling you in upcoming session how this key is going to be exchanged between Miss Anjali and Rahul. Do not worry about it. We'll be talking about it, right? But at this moment, try to understand that Anjali and Rahul has the same key value. Okay. And now Anjali is using some powerful encryption mechanism. By the way, we have some good encryption algorithm in today's world. I will be taking an example of advanced encryption standard, or you can take an example of DES also. These are just the algorithms, right? Or safe or the locks, right? Although if you are pretty curious about learning them, just go and learn mathematics behind it. But if we go into that detail, believe me, this course is not going to over. No doubt about it that the study of AES or DES or cryptography is really, really interesting. But I leave it on you. If you have that much of interest, please go ahead and read. But we will be reading or we will be talking about those concepts, whatever we are going to use in Identity Services Engine course, right? So suppose there is an algorithm which is AES. Anjali is saying that I will be encrypting my message using AES, and AES algorithm also need a key, and that key is going to be K1. What is the meaning? The meaning is Anjali is having this plain text message. She is going to use an algorithm. The algorithm name is maybe say advanced encryption standard. She will be using a key named key1, a number. With the help of these two, she will be generating a ciphertext which cannot be read by anybody on the internet. Suppose this intruder receives this ciphertext. He can't read it. Why? Because maybe he knows the fact that it is encrypted by an algorithm which is known as Advanced Encryption Standard or AES, but the problem is he doesn't know the key with which Anjali has secured this message, which is key one. And this message is received by Mr. Rahul. Mr. Rahul, I do not know how, but Mr. Rahul has this key value. You can think that maybe Miss Anjali called Mr. Rahul to share the secret key, but at the same point, you can say that if Anjali can share the message or share the secret key, she can also share the message over the telephone itself. Why she is using the internet, right? Interesting. But believe me, we will be sharing this key, which is K1, over this unsecure medium, which is internet, and your mind will be, that is going to be mind-blowing conversation. Believe me, and we will be doing sometime. Don't worry. So this ciphertext cannot be read by this intruder, but once the ciphertext reaches to Mr. Rahul is going to use the exactly same steps. He will be using algorithm plus key, the same key value, and then he will be generating the plain text message which he can happily read. Right? Now it's been already 42 minutes, right? And I am open for questions now. Before going into asymmetric key encryption, I would like, if anyone has any doubt, any question, that you can raise your hand and ask question. Anybody? Okay, at least tell me, am I audible, guys? Perfect.
Yes,
Yes.
you are.
Perfect.
Yeah, Vishnu.
Mr. Daniel, you can ask your question. Go ahead.
Thank you very much. I think from the theoretical perspective, I understand what you mean. But will we also talk about it, how this is set up in the practical form, like how our Windows notebooks or Windows laptops or clients are using that specifically?
I will be showcasing you exactly every communication on the Wireshark. Don't worry.
Perfect.
Okay.
Thank you very much.
Yeah, what algorithm we will be using. But yes, how that algorithm is actually going to work, that is going to be absolutely out of scope. Uh, that is the pure and sheer mathematics. If you want, just go ahead and read it, but we will be not covering it. But yes, everything else, right? All the messages flowing, what are the TLS and how this encryption is happening, we will be showcasing you on the Wireshark.
Perfect. Thank you very much.
Yeah. Mr. Abhishek Dimriji, please, you can go ahead and ask your question. Mr. Abhishek.
Yes, sir. So this confidentiality, with what does it mean? You are sharing keys and algo, right? So with like integrity, we cannot change the data. As an authentication, we required username and password. So for the confidentiality, what is the need for mishandling?
Confidentiality is just basically making your messages scrambled in a way so that only the receiver, which is having a key, can read it. Do not get confused with other terms, integrity and authentication. Believe me, what we are doing right now is if you suppose this TLS is a complete circle, we have divided this complete circle into four parts. Right now, we are just talking about confidentiality, only 25% piece of the TLS, right? Until and unless you get the knowledge of integrity, authentication, and non-repudiation, believe me, the full picture is not going to be complete. I am just saying through confidentiality, you are just encrypting the message so that only receiver can read it. With what algorithm, right? It is as simple as that. Just try to understand with a safe example. We have
Yeah,
with,
understood.
yeah, you got, but believe me, I'm coming to the point. I will come to the point of integrity and authentication, why those are kept separate. But this point, I am just interested in just scrambling my message so that nobody can read it. Okay, Mr. Abhishek?
Yes, sir.
Perfect. But be with me, and believe me, after 3 classes from now, TLS is going to be piece of cake for you. Okay, having